Sprayer calibration. It's often a subject that many can find quite intimidating and complicated. About 60% of applicators don't understand how to properly calibrate all of their spray equipment, making it impossible to determine the proper amount of pesticide and solution to add to the spray tank. That's why today I'm going to share a simple, easy method of boom sprayer calibration that will deliver accurate results without the need to work through complicated algebraic formulas. All you need is a few basic tools from home and a test area. Let's get started. So why do we calibrate sprayers in the first place? The simple answer is so that we can ensure that the spray equipment is applying the correct amount of solution uniformly over a given area. During calibration, you are figuring out the amount of solution that is delivered over the given area or the gallons per acre that the sprayer is delivering. Knowing the actual gallons per acre, or GPA, that a sprayer is delivering is essential when figuring out the amount of product and diluent required to spray a given area. Most products recommend different GPA ranges that a sprayer should be operating in during application. So when do you need to calibrate? That depends on a few different factors. First off, sprayers should be calibrated at least once per year, usually in the spring, as the sprayer may need new nozzles or screens. It may have corrosion that plugs nozzles, or may have leaky fittings that need to be fixed. The sprayer must be calibrated more than once per year if the nozzles, pressure, target ground speed, or boom height are changed. In addition, if an applicator changes to a pesticide product with a different GPA range, it will require recalibration of the equipment to the new target GPA. Since traditional algebraic equations can be very confusing to work with out in the field, we are going to use what is called the 1/28th acre method as a shortcut to determining the actual GPA of our sprayer. Since there are 128 ounces in a gallon, we can measure out 1/28th of an acre test strip and measure the number of ounces used on that test strip. Ounces used in this case is directly equal to the actual gallons per acre that we'll be measuring. Before you begin a sprayer calibration using this method, you will need to bring a stopwatch, measuring tape, measuring container, notebook, field markers, and a spray tank that is half full of water. Always ensure the sprayer is clean prior to calibration. The test site itself should be similar to the actual application site that you will be working on. If that is not possible, you need to take into account the terrain, slope, and obstacles of the area you will eventually spray in order to determine field speed. You'll want to be able to operate at the same ground speed on the test site as you would on the actual application site. Order nozzles and screens prior to calibration, and replace your nozzles and screens as necessary. Now that we have everything we need at the test site, we can begin pre-calibration. Start by offsetting the nozzles by 10 degrees. This will eliminate colliding spray patterns, or what we call interference. Next, make sure the spray boom is level with the ground to ensure a uniform spray pattern. To test that the nozzles are delivering a uniform flow rate, place a measuring device under each nozzle and turn the pump on for 60 seconds. If measurements from each nozzle are similar to one another, usually within a 10% error range, then nozzles are delivering a uniform flow rate. Next, we need to determine the target ground or field speed using the basic equation known as the 5940 equation. This step is optional, but it may be helpful for the applicator who wishes to hit a desired target output on the first calibration attempt. If using this equation, you can determine field speed by taking the gallons per minute flow rate of your nozzles and multiplying times 5940. The resulting numerator will be divided by the target gallons per acre, which is found on the pesticide product label, and multiplying times the nozzle spacing in inches. If we want to spray at a rate of 10 gallons per acre and our nozzles are rated for 0.2 gallons per minute and spaced at 24 inches, we would multiply 0.2 by 5940 to get 1188. Then multiply 10 by 24, we get 240. Divide 1188 by 240 to get our answer of 4.95 miles per hour. Now let's figure out our test strip distance. We provided a link in the video description to help you determine this, as it depends on the spacing of your nozzles. Since ours are spaced at 30 inches, we will measure out 136 feet and mark the end points. Next, we will select a gear that will allow us to maintain your target field speed while maintaining a proper engine RPM. We'll maintain that speed as we drive towards the first field marker and start a stopwatch right when the spray boom crosses the first marker, and stop the stopwatch when the spray boom crosses the finish line at the end of the test strip. It's best to repeat this 3 times and calculate the average time between the 3 attempts. Now that we have the average time to drive the test strip, we will turn the spray pump on and place a measuring container under one of the nozzles for the amount of time it took us to drive the test strip. The resulting ounces of liquid collected is equal to what our spray equipment is delivering in gallons per acre. If the GPA that we determine isn't within the target range recommended by the pesticide label, we can adjust 1 or more spray parameters accordingly. Speed is usually the easiest to adjust since it's directly proportional to GPA. In other words, doubling speed will cut the GPA in half. Nozzle pressure can also be adjusted and is on a 2-to-1 ratio, meaning that quadrupling nozzle pressure will double the GPA. If the actual GPA is significantly off from the target GPA, changing nozzle types and restarting the calibration process should be considered. After making necessary adjustments, the sprayer is now calibrated. A complete guide to sprayer calibration is available in the video description. And if you have any additional questions, please contact the Montana State University Pesticide Education Program or your local extension agent. This video was made possible via funding from the USDA and the Montana State University College of Agriculture. I'm Cecil Tharp, Montana State University Pesticide Education Specialist. Thank you for watching.